The net present value of a series of cash flows is their value today. You can't just add up the cash flows to get this number because $1 today is worth more than getting $1 in the future. This is called the time value of money. The economic theory behind this is that if you give me $1 today, I can invest it to get more than $1 in a year. For example, I can put it in a savings account and get $1.03 in a year. That assumes I'm perfectly rational and self controlled. Economists' assumptions aren't based on normal people that have a knack for losing money from bad decisions, lack of control, or bad luck. The huge assumption with NPV, aside from the cash flows, is the discount rate. What rate should you use? A good starting point is your weighted average cost of capital. In other words, what's the weighted average cost of the funds you will use? Let's say your owners expect a 10% return on their cash and you can borrow money at 6%. If the location is financed by cash, you would use 10%. If you were funding half of it with cash and half with debt, you may use 8%. You should then adjust that for the riskiness of the project. I'll talk more about that later. Excel has two NPV formulas. NPV, the formula for this is NPV, and in parentheses, you put in the discount rate and the series of values. One thing to note about the formula is that it assumes the cash flows occur at the end of a period. Most of our cash outflows occur at the beginning of the year. So you'll see in the metric analysis worksheet that I run the NPV formula for years 2 through 5 and then add the first year's cash flows. XNPV. The formula for XNPV is XNPV, and in parentheses, you put the discount rate, a series of values, and dates for those values. This allows you to pair an exact date for each cash flow rather than using the end of period assumption of NPV. Here is a table of the cash flows discounted by an assumed 10% discount rate. What you are hoping for is at least a positive number. Your discount rate should be the risk-adjusted minimum rate of return you would want from the project. When comparing projects, you would lean toward picking the projects with the highest net present value. In this example, the NPV is negative, which means we may not want to open the new location. It may still make sense to open the new location if there are qualitative factors that offset the negative NPV. NPV can change based on how many years you project. I only projected 5 years in this analysis. If I project 2 more years of $155,000 of cash flow, the NPV jumps to $136,502. The longer in the future you project numbers, you are also less certain of the cash flows. This is why you may be okay only projecting 5 to 10 years in the future. If you are buying or constructing the location, make sure to put the sale value of the building at the end of the cash flows. Some of you may have identified another option to improve NPV over the first 5 years. Use debt to lower the cost of capital. Using debt reduces current cash outflows and lowers the discount rate because it's a cheaper source of capital than equity. The table below shows borrowing $200,000 in the first year, paying it back over 4 years at 6% interest, and discounting the cash flows at 8%. Now the NPV has improved to minus $14,789.